Monday morning, your boss calls you into a conference room, and then he says, "So, I called you in here because I've got a new project for you."
Okay.
What I'd like you to do is write a program that copies characters from the keyboard to the printer.
All right. Anything else?
No, that's about it. How long do you think that's going to take you?
I think this is about 6 lines of code. 3 weeks.
Excellent. Let's get started. 3 weeks is the minimum estimate where you work. If anybody gives an estimate less than 3 weeks, he's taken out back and soundly beaten by the other programmers. The reason your boss went away happy is he got the minimum estimate. The first thing you do is draw a diagram, because, as you know, all programmers draw diagrams before they write code. The copy module contains all the high-level policy. It contains the main loop that gets characters from the keyboard reader and sends them to the printer writer. It also recognizes the end-of-file condition and exits. This diagram looks good, and you're about to write the code that matches it, but your boss walks in with a new guy that you've got to orient today, and you got to show him the ropes, and it takes all day long. So that's going to pretty much eat up Monday. Tuesday, you write the code. It looks like this. It's the 6 lines you had in your head. A simple loop that terminates on end of file and otherwise copies characters from the keyboard to the printer. You're about to compile it when you realize you're late for a quality meeting that's going to take all day. Wednesday, you compile the code, and it compiles right away, too. That's a good thing because right after that, the field service manager rushes into your cubicle with a horrible bug in the field, and you're going to have to go fix it. It's going to take you all day. Thursday, you test the code, and it works first time you run it, too. Good thing because your boss comes in and hauls you into some horrible cross-functional meeting that's going to take all day long. Friday. No meetings, no bugs, no interruptions. And it's a good thing, too, because it takes all day long to get this code into the source code control system. Whoa! You're done with 2 weeks to spare. But don't let your boss know that you're done early. You better keep busy with other stuff, and then you can release it on time. You win awards for this software. Hundreds of other programmers start to use it in their systems. It's so successful, those 6 lines of code may be the most successful lines of code ever written at your company. A few months later, your boss comes to you and says, "So, you know that program you wrote, that copy program?
Yep.
That was great work, and you're going to see our appreciation in your next salary review. So now what we'd like is for it to read from the paper tape reader."
That's it? Just read from the paper tape reader?
Sometimes from the keyboard, sometimes from the paper tape reader.
Okay.
How long do you think that's going to take you to do?
This sounds like a Boolean and an if statement. 3 weeks.
Good. Let's get started on that. So now you modify the diagram to show the new dependency upon the paper tape reader. So how should you modify this program? You could pass a Boolean into the copy program, but that changes the signature of the function. And all those other hundreds of programmers that used your function are going to have to recompile and retest if you do that. So they'll come to your cubicle with clubs. No, it's probably better to use a global. It's a simple idea. If someone wants to copy from the paper tape reader, they'll just set the GPT flag variable to true, and then they'll call copy. They'd better remember to clear that flag when they're done. Otherwise, the next caller will get a surprise. You can cover your butt with an appropriate comment like so. Remember to clear. Okay, so now we have to make this work. The best feature of the C family of languages is the ternary operator. It allows you to put whole if statements into a single expression. So we'll just insert it into the program like so, and voila! A few months later, your boss asks to see you again. So you know that copy program you wrote?
Yep.
Sometimes we'd like it to write to the paper tape punch.
I've got a design pattern for this now. I know how to solve it. 3 weeks.
Great! One more addition to the diagram, adding yet another dependency to the copy module. The change to the code is simple. Just one more global right here. You can reuse the comment. And now you can add another ternary operator just like so. There, that'll work. Ship it. This code is rotting. It's pretty clear that your boss is going to keep coming back to you with more and more changes. He'll want to read from the optical character reader and write to the voice synthesizer. There'll be no end to it. And so that module will grow and rot and fester and degrade. A few years from now, it'll be time to polish off your resume and leave that mess to somebody else. Of course, it didn't have to be this way. We could have written the code like this. Yes, this looks just like the original 6 lines, but there's a small difference. Instead of reading from the keyboard reader and writing to the printer writer, we're reading from getchar and writing to putchar. Getchar reads from standard input, which defaults to the keyboard. Putchar writes to standard output, which defaults to the printer. So this version does exactly what the previous version did. However, standard input and standard output can be redirected to other devices like the paper tape reader and the paper tape punch. This means that when your boss says, sometimes we need it to read from the paper tape reader, you've got an option. You could say
3 weeks.
Or you could tell him that it already does read from the paper tape reader. This code differs from the previous code by 2 words, and yet those 2 words somehow prevent the code from rotting when you add new devices. In fact, adding new devices, you don't even have to recompile it. Just what's so special about these 2 words? How have they so completely changed the maintenance characteristics of this module and utterly stopped this code from rotting? To understand why those 2 words are so important, let's look at the diagrams again. Here's the diagram of the first solution. The copy module depends on the keyboard and the printer. Look at the direction of those arrows. The module that contains the high-level policy depends on the low-level details. And when we added new devices like the paper tape reader and the paper tape punch, we had to add new dependencies to the copy module. So the fan-out of the copy module grew with each change. But now look at the diagram for the new version. Copy depends upon getchar and putchar, but does not depend upon the keyboard and the printer. What is it that fills the gap between those 2? It turns out that getchar and putchar are part of a Unix abstraction known as file. This abstraction is represented by a data structure that, among other things, contains a table of 5 pointers to functions. Those functions are open, close, read, write, and seek. The I/O drivers for the keyboard, printer, paper tape reader, and paper tape punch implement those 5 functions. So when you redirect standard input and standard output, what you're really doing is loading those 5 functions into the file abstraction. That means that the I/O drivers depend on the file abstraction. Now, look at these 2 diagrams side by side. Notice the inversion of the dependencies. In the first version of the code, the dependencies point in the same direction as the flow of control. But in the new version, the dependencies oppose the flow of control. This inversion of dependencies prevents the system from rotting because it stops the fan-out of the copy module from growing. The copy module doesn't need to be modified because all of its outgoing dependencies terminate at the file abstraction. New devices can be added ad nauseum without affecting the copy program one little whit. Now consider this. Those 5 functions in the file data structure are exactly equivalent to C++ vtables used to implement virtual functions. They're logically equivalent to the polymorphic dispatch mechanisms used in Java, C#, Python, Ruby, Smalltalk, and every other OO language. This means that getChar and putChar are logically equivalent to polymorphic methods on a class name file. So the new version of copy is really an object-oriented program. This program may not look OO to you because it's written in C, and C is not an OO language. But that's not really important. You don't need an OO language to write an OO program. All you really need to do is to invert key dependencies by using dynamic polymorphism. To make this point clearer, take a look at this diagram, which is the logical equivalent of the getChar putChar solution. And yet it's clearly an object-oriented program. File is an interface which is implemented by the 2 I/O drivers for the keyboard and the printer, and it's used by the copy algorithm. And here's the code. Again, it's semantically identical to the getChar putChar solution, but it's written in an OO language. Notice the inversion of the dependencies. The keyboard and the printer derivatives of the reader and writer interfaces depend in a direction that opposes the flow of control.